Hi everyone. I thought that it might help for you to correct using a video so that way you can go at your own speed. My expectation is that you're using a different colored pen and that you actually make corrections. So mark it wrong if it is wrong, but then make corrections using a different colored pen so I can see your original answer and then how you corrected it. This is one of your last chances to learn how to do these problems before your common assessment. Okay, so the first 5 problems are the minimal, expressing in scientific notation in standard form and then deciding which is greater. So, to write a number in scientific notation, remember you are moving the decimal until you have a number that is between 1 and 10. So that is 2.345 times 10 to the, and then how many places did you move the decimal? We moved it 1, 2, 3, 4, 5, 6, 7, 8 places. It was a large number, so it is going to be a positive exponent. 1, 2, 3, 4, 5, 6, 7. And I always double check one more time. 1, 2, 3, 4, 5, 6, 7, 8. All right, the next one, we move the decimal 1, 2, 3, 4, 5 places until we come to a decimal that is between 1 and 10. Notice we did not reverse the numbers. We kept them in the same order, and then times 10 to the, we moved it 5 places, but the number is very small, so our exponent is going to be negative. So, to write in standard form, we're moving our decimal to get rid of multiplying by a power of 10. If it is a negative exponent, like here, it is going to become a smaller number. So 0.775. Where here, it is becoming a larger number. So, and we're moving it 7 places. 8, 3, so that's one of the places, and we have to go 6 more places. 1, 2, 3, 4, 5, 6. I'm going to put my commas in every third from the end, and then I'm going to double check one more time. 1, 2, 3, 4, 5, 6, 7. So that's perfect. All right, circle the larger value. 5 times 10 to the third or 6 times 10 squared. Remember, if the first place you look, if you're trying to figure the larger value, is the exponent, the 2 and the 3. The 3 is larger, so that's my answer. And your explanation should be something like the larger exponent means there'll be more place values. And I'm not going to write that all out, but something like that. The larger exponent means there are more place values. All right, 6 through 9 are your basic level questions. I can perform some calculations using scientific notation without the need to rewrite the final answer. 6 through 9. Okay, so with multiplication, remember your first step is to regroup. 2.5 times 3 times 10 to the 5th times 10 to the 4th. You are more than welcome to use a calculator to do the multiplication if you want to. That is 7.5 times 10 to the, and when we are multiplying powers with the same base, you add the exponents. So 7.5 times 10 to the 7th. With addition subtraction, the first thing you look at is whether the exponent's the same. If it is, you just add or subtract the decimals. So it is the same, so I'm going to subtract 3.2, which gives me 3 there. 4 minus 3 is 4. So 4.3 times 10 to the, and you keep the exponent the same. Remember, as I'm going through these, you should be correcting your paper, leaving your old answer the same, correcting it, but make sure you mark it wrong. With division, you divide the exponents. 4 goes into 5 one time with 1/4 left over, so that's 1.2. 0.25 times 10 to the, and then you deal with the bases. When you're dividing powers with the same base, you subtract the exponents. 12 minus 4 is 8. Again, with addition, you have to look to see if the exponents are the same. With multiplication, you don't, but you cannot add until these are like terms and they have to have the same exponent. So we always take the smaller one and make it bigger. So to get from 6 to 10, we'd have to add 4. So now we have 10 to the 10th. And since we made the place value 4 bigger here, we have to make the place value 4 smaller here. 1, 2, 3, 4. So 0.00035. And now we can add it. So I'm going to do the decimal part off to the side, 4.2 plus 0.00035. I'm going to put my zeros in, and feel free again to use a calculator if you want. So I have 4.20035 times 10 to the, and we are going to keep the powers the same, 10th. All right, another division problem, but remember there are going to be times when you're multiplying and dividing it is not in scientific notation. So you need to make sure it's put in scientific notation. So we are going to do our decimals first. 6 goes into 24 4 times, but there's a decimal, so it's 0.4. Or set it up like this. 6 goes into 24 4 times, so 0.4 times 10 to the. When you're dividing powers with the same base, you subtract, and I'm seeing many integer errors. Make sure you write it out like this and do that keep, change thing. -3, we're going to keep, change. So now we have -3 plus a -2. So if you have 3 negatives and add 2 more negatives, it's going to be 5 negatives total. But this is not in scientific notation. This right here is not in the correct spot, so we have to move it over here. So we're going to make this one place value bigger, so we have to make this one place value smaller. And again, I highly suggest you write it out so you can do keep, change. So now we're at -6. All right, last problem like this. It's a multiplication, so we're going to regroup 2.04 times 2.3 times 10 to the 15th times 10 to the -8th. And we're going to do this part first. And feel free to use a calculator, or you can write it out either way, but that's not what I am testing you on. So 2.04 times 2.3 is 4.692, and then when we are multiplying powers with the same base, we add the exponents. So 15 plus a -8 is 7, and this is in scientific notation, so this is our answer. All right, first let me point out that yes, this was a mistake. Thank you for pointing it out to me. This was supposed to be, of course, 2014. So in 2010, there were 9.5 million iPads, and there were approximately 67,990,000 iPads purchased globally. How many more iPads were bought in 2014 than 2010? How many more means subtraction. Okay, so I just took a little break to write out the numbers. So I took this 9.5 million. So here is the 9.5, and I made sure it was million. So that's like 9,500,000. And then I put the second number in scientific notation. 2014, there was more purchased than in 2010. So this one is the larger number. So we are going to move this, we have to make the exponent 1 bigger. So now I have 9.5 times 10 to the 7th, and I can do my subtraction. So again, sometimes you might have to borrow, but you can always use a calculator. So 5.849 times 10 to the 7th, and that is how many more? So it's iPads, but it's said to write it in both scientific notation and standard form. So that is moving the decimal 7 places. So that would be 3, 4, 5, 6, 7. So in 2014, and I did try to find real numbers compared to 2010, there were 58,490,000, this is an approximation, iPads bought. So that's a huge number. All right, next problem. The speed of light. So speed is right here. If the planet mass is this many meters away, so that's your distance, how many seconds does it take? So we can do it a couple different ways. Distance equals rate times time, or that triangle. I like the triangle because we have the D, and this line means multiplication, and we have the R. So we are dividing the distance by the rate. So 6 divided by 3 is 2 times 10 to the, and we're dividing powers of the same base, we subtract. So 10 to the 2, and that's in seconds. So 200 seconds. How many times greater? How many times greater? So we are dividing 9 times 10 to the 4th divided by 3 times 10 squared. 9 divided by 3 is 3. We're dividing powers with the same base. You subtract, so 4 minus 2 is 2. So it is, or 300 times greater. Again, you should be correcting right now, so mark it wrong, but also correct so you can see what it is you're doing wrong. 2 more problems. One widget has one diameter, another cell has another diameter. What are their combined diameters? Combined, remember, means addition. So we're going to first look at our exponents. They are not the same. So we have 2.5 times 10 to the negative 5th. And we're adding to that 3.8 times 10 to the negative 7th. We've talked about always changing the one that has the lesser. So negative 5 and negative 7. Negative 7 is less than negative 5, so we're going to change this one. So we have to add 2 to get to negative 5. And if we're adding 2 place values in the exponent, we have to take away 2 place values. So now we have 0.038 times 10 to the negative 5th. And we are adding, so 0.038. So now, once we combined these, I have 2.538 times 10 to the negative 5th, and we're talking millimeters. So that is your answer. And lastly, another distance equals rate times time. Here we have miles per day is the speed. So we have the rate or the speed, and how far will it travel in. So how far is, we're looking for the distance it's going to travel over a period of time. So we know the speed and the time, so we multiply 4 times 10 to the 5th times 2.5 times 10 to the 3rd. So 4 times 2.5, you can use a calculator if you want, or you can think 2.5 twice is 5, 4 times is 10. So now we have 10 times 10 to the, when you're multiplying powers with the same base, you add the exponents. And then hopefully you notice this was not in scientific notation. So we have to move this over. 1 times 10. If we made this one smaller, we have to make this one place value bigger. So 1 times 10 to the 9th. And we are in, remember we're trying to find how far, so we can go back here, miles per day. So that means we must be in miles. That's it. Please make sure you go back and re-watch any part that you need to watch and do the final summative review for tomorrow's common assessment. We out.